wonky coins and also how to make wonky coins more proficient. Right now, what we're going to do is we're going to write a function that's going to sort an array. And the problem for us is going to be how we sort the array. So write a function, BubbleSort, which will sort an array of integers using the BubbleSort methodology. So what is that? We'll click on this little link right here. And let's see if I think I have a, yeah, so here it is right here. This little infographic will kind of show what happens here, right? So you'll compare two numbers next to each other, and if one's bigger than the other one, so one to the left is bigger than the one to the right, you'll switch. So here, 6 is bigger than 3, and you'll switch it, right? You'll keep on moving down the array and keep on iterating through the array over and over and over again until the array are sorted, until there's no more way you can switch, okay? So let's write this out. So here's from my wonky coins efficiency. Let's kind of get rid of that right there. Boom, 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 boom. So just to think about this, we're going through, and it makes sense. This would be kind of like a way of sorting something. You're going through, you're comparing the two items next to each other, and if one is bigger, you flip. Okay. So let's make an array. So 3, 2, 4, 1. Okay, let's make this array right here. So first we're going to compare 3 here and then 2 here. Is 3 bigger than 2? Yes. So in the next iteration, the array is going to look like this. 2 here, 3 here, 4 here, and then 1 here. And then close. So 2, 3, 4, 1. Right? So we flipped it. Now what we're going to do is we're going to look at this one. So we just move over 1 and this one. Okay, so we started here. We compare this one to this one. Now we're going to move over. So 3 and 4. Is 3 bigger than 4? No, it's not. This is correctly sorted. Okay. So the next iteration, so we iterate again. 2 is here. That's correct. 3 is here. That's correct. 4, right? And then 1, right? So now we're going to look. 4 and then 1. Are those, is 4 bigger than 1? Yes, it is. So that means the next iteration is going to look like this. It'll be 2 here, it'll be 3 here, it'll be 1 here, and then it'll be 4 here, right? So 2, 3, 1, 4. Cool. So that's just one iteration through. So now we've made it to the end, okay? And we're not going to compare it to here because this right here is actually nil, right? So we're not going to compare there. So once you're at the end of the array, then we're going to go back to the first item and then compare it again to 3, right? And that's sorted order, and so on and so forth until finally the array is going to look like this. 1, 2, I'm not very big, 3, and 4, okay? So that is our goal doing using this methodology, okay? And so the question is, well, it makes sense. The first thing we're going to do is compare each item to the next one and go through the array. Okay. So the first thing, let's going to write that out. Okay. So let's write this out. Compare two adjacent two items next to each other, and if the one to the left is bigger, then flip and switch them. Switch places. Right, this is the first thing I do. Keep doing this until array is sorted. Right. So keep performing that until the array is sorted. Is sorted. Right, so let's just write that out. Okay? So let's just code that out. So we're start at 0, so the first index of the array, up until array dot length minus 1, right? So the last index. You'll see what I'm going to do here. And so now for each index, what I'm going to do for that, so for each index, I is going to stand for index right here. So for each index, what I'm going to do is if the array of the current index, right, is greater than, so the element at the current index, right, element at the current index, so remember going back here, so 3, we're comparing 3 to 2, we're seeing 3 versus 2, right? If that is greater than array of the next index, then we're just going to flip. And all we're going to do here is I'm just going to say flip, switch. I'll put a little comment here, switch. I'm going to assume that we have that coded out, okay? It's actually pretty easy to do it in Ruby. So we'll switch it. Cool. Now let's think about how we want to, I'm going to put my ending tag here. Make sure those ending tags all work. I'm just going to kind of move these over a little bit, kind of make it a little more cleaner looking. So move these over. So I'm looking here at these lines. Help them keep in track for me. So let's see here. So we got the switch, but now we're going to keep on doing that until the array is sorted, right? Well, in Ruby you can kind of write that out pretty simply, right? We can say until it's sorted, okay, until it's true that it's sorted, keep doing this. Keep it's true, keep doing this, right? So that means if you do flip this, that means sorted is false. That means the array has not been sorted yet, right? So array will be false. Now, once you go in here, let me figure out a way to break out of this, though. You can keep on looping infinitely over and over and over and over again, okay? So when we can do that is we can just say, immediately start sorted as being false, okay? And then let's say that once it gets in here, nothing ever happens here. So it never gets into this conditional statement right here, actually. So this actually should go down right in here. Oop. So let's say it never gets into this conditional statement, okay? Never gets into this conditional statement. Never equals false. That means we need now, so this equals false here. This equals false. That means this is equal to false currently here, right? We're going through the array, we're going through the index. Let's say we have a sorted array. It's not going to stop because it's currently equal to false, right? Not unless as soon as we come into this loop here, which I also need to put the ending in. So I'm just going to move this over one more time. Boom, boom. So that's the way it's until it has an end. So we can break out of it. Cool. So what we're going to do is, well, let's assume that sorted once it comes in is equal to true. Okay? So that means that'll be the default value once it breaks out of this loop and it never goes into here. And once it breaks out of the loop, that means it'll never go back again. That means it is sorted. That means at the end, we can just return the array, right? Because that means the array is sorted. So for Ruby, all you have to do in order to switch these two indexes is this. You can just compare them, boom, boom, like this. And what you say is you put comma here, you say equal here, one more time. You can move this over a little bit so you can see this a little more clearly, right? Comma here, index plus 1, index here. Good. Right? So now we're following literally how we would talk about this. We're assuming, first off, that the array is not sorted, which most of the time when you're giving something, well, this is the main example right here, isn't sorted, okay? So it's false, not sorted. It comes in here. We're going to compare, right? Then if they do make the flop, that means you know that the array has not been sorted yet. Boom, it's not sorted. And we can go back into it. Keep on repeating. And once it doesn't go into this conditional statement, then we know it is sorted, we can return the array. Cool. Let's see if this works here. Whoop. Comparison integer with no failed. So I compared, so my comparison, I compared to the next possible index, okay? So it means I went out, just like I did over here. We don't want to compare out, because that means no, this is exactly what I did right here, right? I compared it to a nil value. Okay, so in order to fix this, what I'm going to do is I'm going to put that right there, and that should fix it. Boom, boom, boom. Awesome. So what this does right here in Ruby, it means don't include. So I was including the last one. Okay, that means that it was going through each index, and instead of stopping on this index and only comparing it to the next one right here, let's make a new way to make it more clear. So this is index 0, this is index 1, this is index 2, this is index 3, okay, this is index 4. So what I have written right now is that it was going to the last index and it was including it into the indexes here. So this is what this is right here. I made a list from 0 up to the last index, right? I was including that in. So that means it was comparing this one to the next one here, right, which is nil. And you can't do that, okay? So all I did was right now was put this dot right here. And this means do not include, right? And so that means I stopped here and here, and that allowed the algorithm to run. Now we're all good. And that's BubbleSort.